Problems based on composition of functions. Problems based on composition of functions. If gx equal to x square plus x minus 2 and 1 by 2 into g circle f of x equal to 2x square minus 5x plus 2, then fx is equal to, the options are 2x minus 3, 2x plus 3, and third one is 2x square plus 3x plus 1, and fourth one is 2x square minus 3x plus 1. The composition of two functions is given here, and out of the composition one function is given, the other function is needed here. This is one important model. So here 1 by 2 into g circle f of x is given as 2x square minus 5x plus 2. That gives us g of f of x is 4x square minus 10x plus 4. Okay. G of f of x. G of f of x is fx whole square. Okay. Now this is 2x, this is 2x whole square. Okay, 2x minus 3 whole square plus 2x minus 3 minus 2. It can be written as 2x minus 3 whole square plus 2x minus 3 minus 2, because 4x square minus 12x plus 9. Similarly, plus 2x minus 3 minus 2. From these two we get minus 10x. From this we get plus 4. So we will arrange like this, in this form, based on the coefficients, we have to arrange this function. So this is fx whole square plus fx minus 2, g of f of x, where fx is 2x minus 3 itself. Hence the required function is 2x minus 3. Now, composition of mappings. This is given in IITs. If fx equal to alpha x by x plus 1, comma x not equal to minus 1, then for what value of alpha is f of x is x. For what value of alpha, f of fx is x itself. F of x is alpha into fx by fx plus 1. That is alpha into alpha x by x plus 1 by alpha x by x plus 1 plus 1 itself. Now that is alpha square x by x plus 1 into x plus 1 by alpha plus 1 x plus 1. Taking LCM and taking x common, alpha plus 1 into x plus 1. You can remove this one. That is alpha square x by alpha plus 1 x plus 1. Now, f of x is x implies alpha square x by alpha plus 1 x plus 1 is x. Taking cross multiplication without removing, taking cross multiplication, we get x square plus x. So that is alpha plus 1 x square minus alpha square x plus x is 0, which is alpha plus 1 x square minus of alpha square minus 1 x is 0. That gives us alpha plus 1, of course x into alpha plus 1 x minus alpha plus 1 into alpha minus 1 is 0. X is not 0. Once x is 0, the function is fx is 0 itself. So therefore, alpha plus 1, taking alpha plus 1 into x into x minus of alpha minus 1 is 0. This is not equal to clearly 0, x, because x equal to taking alpha plus 1 minus alpha plus 1. Okay. Clearly, once alpha plus 1 is 0, x not equal to minus 1. Once x equal to minus 1, then what happened? Minus 1 minus alpha plus 1, which gives us alpha is 0. In such case also, fx is 0. So therefore, alpha plus 1 equal to 0 implies alpha takes the value minus 1. The required value of alpha is here minus 1. These are all based on composition of mappings. If fx equal to 2x plus 1 by 3x minus 2, then f circle f of 2 value. If fx equal to ax plus b by cx minus a, these two are equal. Once these two are equal, then consider f circle f of x. That is a of x plus b by c of x minus a. That is a into ax plus b by cx minus a plus b by c into ax plus b by cx minus a minus a. Now on simplification, this is a square x plus ab plus bcx minus ab by acx plus bc minus acx plus a square. So this ab cancel. Here acx cancel. So f circle f of x is taking x common in the numerator. We get a square plus bc into x by the denominator we get a square plus bc, which is equal to x itself. Once these two are equal, f circle f of x is always x. Hence, if fx equal to x plus 1 by 3x minus 2, then f circle f of x is x. That implies f circle f of 2 is 2 itself. In this case, f circle 4 times, taking 4 times. 3 times we get fx in this case. F circle f, taking 4 times we get again x. Like that. Once even number of times f is operated, we get x. In case of odd number of times f is operated, we get fx. That is one important point related to the composition of mappings. Once even number of times is operated f on x, we get x itself. Odd number of times operated, it is fx. If fx equal to a minus x power n whole power 1 by n for a greater than 0 and n being a positive integer, then f circle f of x, f of x value. Okay. This is also one interesting question. Here fx is a minus x power n whole power 1 by n. F circle f of x is f of x, that is a minus fx power n whole power 1 by n. That is a minus fx is again a minus x power n power 1 by n whole. This is fx whole power n power 1 by n. Here is fx. This is fx. Now this n cancel, so that we get a minus a plus x power n whole power 1 by n. A cancel. X power n whole power 1 by n, that is x itself. Here f circle f of x is x itself. A may takes any positive real, and n being a integer, positive integer. F circle f of x is x. F circle f is fx. F circle f is 4 times operating on x, we get x once again. So like that we can operate even number of times and odd number of times. F on x. Next problem. Suppose gx equal to 1 plus root x and f of gx equal to 3 plus root x plus x, then fx equal to. Let us consider the options here. 1 plus 2x square, b is 2 plus x square, c is 1 plus x, d is 2 plus x. f of g of x. F of g of x is 3 plus 2 root x plus x, then fx value. Okay. Given f of g of x, write this function in terms of gx. So that is 2 plus 1 plus 2 root x plus root x whole square. That is 2 plus 1 plus root x whole square, which is 2 plus gx whole square. Hence, f of x is, replacing gx with x, we get 2 plus x square. Hence, the second option is the right option. Write this function in terms of gx. Fx equal to x plus 1 whole square. Gx is x square plus 1. Then f circle g of minus 3 value equal to f circle g of minus 3 value. Let us consider f circle g of x here. F of g of x. F of g of x is gx plus 1 whole square. Replacing x with gx, we get gx plus 1 whole square. Whereas gx is x square plus 1 whole square. So x square plus 2 whole square. Hence f circle g of minus 3 is 9 plus 2 whole square, 121. The required value is 121. Like that, we can develop the composition of mappings. Composition of mappings. Finding of the inverse functions. Problems based on finding of inverse functions. F from R to R, set of real numbers to set of real numbers, is defined by fx equal to 3x minus 4, then f inverse x is f defined from R to R and given by fx equal to 3x minus 4, a linear function. Then f inverse x. Here f dash x is 3 greater than 0. So clearly 1 1 injective function, because it is monotonically increasing function. And it is also it takes all the real values. It takes all the real values corresponding to each and every real value in the domain. So hence it is onto also. So fx equal to 3x minus 4 is a bisective function, clearly. Bisection. Bisection means 1 1 and onto. That is 1 1 and onto. Since it is 1, 1 and down 2, it has inverse. So to get the inverse, let y equal to 3x minus 4. That gives us right x in terms of y. That is y plus 4 by 3. Therefore, f inverse of x is replace y with x here to get the inverse function. Clearly it exists. It belongs to R. So hence, once y is a real number, y plus 4 by 3 is also a real number. It exists. Hence, f inverse x equal to x plus 4 by 3 itself. Similarly, the inverse of the function fx equal to 10 power x minus 10 power minus x by 10 power x plus 10 power minus x is the inverse of the function 10 power x minus 10 power x by 10 power x plus 10 power minus x. To get the inverse, let us consider the function as x, y, that is 10 power minus x. This is 10 power x minus 1 by 10 power x by 10 power x plus 1 by 10 power x. Now on simplification, 10 power x whole square minus 1 by 10 power x whole square plus 1. So taking cross multiplication, we get 10 power x whole square minus 1. Write x in terms of y. To write x in terms of y, collect 10 power x whole square terms. That is y minus 1 into 10 power x whole square, it takes the value minus 1 minus y. So 10 power x whole square takes the value y plus 1 by 1 minus y, or 1 plus y by 1 minus y. This is 10 power 2x equal to 1 plus y by 1 minus y. Hence 2x takes the value taking logarithm 1 plus y by 1 minus y to the base 10. So x in terms of y is 1 by 2 log 1 plus y by 1 minus y to the base 10. This is the inverse of the function valid for y not equal to 1. Y not equal to 1. Okay. If y equal to 1, then 10 power x minus 10 power minus x equal to 10 power x plus 10 power minus x. So 10 power minus x equal to 10 power minus 10 power minus x, which is not possible. So except at y equal to 1, the inverse function of the function is valid. Therefore, f inverse x defined as log 1 plus x by 1 minus x. 1 plus x by 1 minus x. Half into 1 plus x by 1 minus x for x not equal to 1. In such a way, you can able to find the inverse of the function once it is invertible. Invertible means it is bijective only, it is invertible. Let f be the function defined from pi by 3 comma pi by 6 to b, defined by fx equal to 2 cos square x plus root 3 sin 2x plus 1, where b belongs to the closed interval a comma b, such that f inverse exists. F inverse exists. Then a plus b. Then a plus b is f defined from pi by 3 to pi by 6 to b. So that fx is 2 cos square x plus root 3 sin 2x plus 1, where b is the codomain is a comma b, so that f inverse x exists. Then a plus b. Once f inverse exists, this codomain is range of f itself. That should be observed here. F inverse of x exists, then range of f equal to the codomain b itself. The range of f. So here we have to find the range to get b. That means AB. To get the range, so here f of x is given as 2 cos square x plus root 3 sin 2x plus 1. That implies f dash x is 4 cos x, derivative of cos x is minus sin x, plus this is root 3 into 2 cos 2x, derivative of 1 is 0, which gives us this is minus 2 sin 2x plus 2 root 3 cos 2x. Okay. 2 root 3 cos 2x. This is equal to 2 into root 3 cos 2x minus sin 2x, which is, of course, this is 1 by 2 into root 3 by 2 cos 2x minus 1 by 2 sin 2x itself. That is 4 into root 3 by 2 may be written as cos of, otherwise sin. I will take sin here. Sin pi by 6 cos 2x minus cos pi by 3. This is pi by 3. Sin 2x. Sin a cos b minus cos a sin b. Sin of a minus b. Sin of a minus b. That means 2x minus pi. As x lies between pi by 3 and pi by 6. As x lies between pi by 3 and pi by 6. For x lies between pi by 3 and pi by 6. This is actually the given interval is pi by 3 and not pi by 3 and pi by 6. I thought that this is 6 and 30 and this is 6 and 3. 2x is pi by 3 is less than or equal to 2x is less than or equal to 2 pi by 3. That implies 0 is less than or equal to 2x minus pi by 3 is less than or equal to subtraction of pi by 3, we get pi by 3. Hence, sine of 2x minus pi by 3 is less than or equal to sine 0, 0, sine pi by 3, sine 60, sine 60 is root 3 by 2. So hence this is clearly positive, f dash x is clearly positive for all x that belongs to domain of the function. This is clearly positive, this one is clearly positive, f dash x is positive. Therefore, the given function is an increasing function. The given function is an increasing function in the interval. Therefore, f is increasing in pi by 6 to pi by 3. Strictly increasing because f dash x is greater than 0. F is strictly increasing in the function. So therefore, range of f is nothing but f of pi by 6 and f of pi by 3 itself. F of pi by 6. F of pi by 6 means taking x equal to pi by 6 here. That is x equal to pi by 6, 2 root 3 by 2 whole square plus root 3 into sine 2x means sine pi by 3. Sine pi by 3 again root 3 by 2 plus 1. This is 3 by 2 of course plus 3 by 2 plus 1. This is 3 plus 1, 4. This is 4 LCM, 3 by 4 means 3 by 2 only, 3 by 2. 3 by 2 plus 3 by 2 is 3. 3 plus 1, 4. F of pi by 6 is 4, comma. F of pi by 3. F of pi by 3 is taking x equal to pi by 3, that is cos pi by 3, cos 60. 1 by 2, its square is 1 by 4, so 2 into 1 by 4 plus root 3 into, this is 2 pi by 3, 2 pi by 3 means pi minus pi by 3, sine of pi minus pi by 3 is root 3 by 2 itself plus 1. This is 1 by 2 plus 3 by 2 plus 1, 2 plus 1, 3. That gives us 3. Okay. Once again you go through the values here. Pi by 3. Pi by 3 means this is less value. So f dash x is 2, 4 cos x minus sin x minus 2 sin 2x root 3 into 2 cos 2x. Taking 2 common, root 3 cos 2x minus sin 2x. Okay. That is 2 into root 3 by 2 cos 2x minus 1 by 2. This is sin pi by 3. Okay. Cos 2x minus cos pi by 3 sin 2x. So sin of 2x minus pi by 3. Okay. Actually this value is less than this one. Hence fx lies between 2x minus pi by 3. Taking minus pi by 3, 0, minus pi by 3. Sine value, it takes value, and instead of taking 2x minus pi by 3, oh sorry, this one is plus and minus, sine of a minus b, this is a and this is b. Okay. Hence this one is minus sine 2x, sine 2x is here, this one is minus sine 2x is less than or equal to minus 2 pi by 3 is less than or equal to pi by 3 minus. Adding pi by 3 to this one, taking plus, we get minus pi by 3 is less than or equal to 0. So sine in the fourth quadrant, sine in the fourth quadrant is minus sine pi by 3 and sine 0, which is negative clearly. Okay. So therefore f dash x is negative. So f is in its domain. For x belongs to domain of the function. This is decreasing. Hence this is 3 and this is 6. Hence this is 3 and this is 4. So which is equal to AB here. AB. So a plus b is 7. The required value is 7. Once f inverse exists, the codomain must be equal to range. So it is sufficient to find the range of the function to get AB. So to get the range of the function, observe whether the given function is either monotonically increasing or decreasing. Since it is decreasing function in the given domain here, so the values interchange. Once it is decreasing, the values of interchange here. The functional values interchange. F of pi by 3 is minimum, f of pi by 6 is maximum. The corresponding range is given by f of pi by 3 and f of pi by 6, which is 3, 4. Hence a equal to 3, b equal to 4. Okay. Question based on the ranges and maximum minimum values of the function. Next problem. Nature of the functions, based on problems and based on the nature of the functions. The total number of onto functions defined from the set that consists of 4 elements 1, 2, 3, 4 to the set F that consists of only 2 elements. The number of onto functions defined from the set that consists of 4 elements to 2 elements. Number of onto functions from set A to set B, where n of A equal to m and n of B equal to 2 is 2 power m minus 2. The number of elements in A domain is m. The number of elements in codomain is 2. Then range set is 2 because onto mappings. So total number of functions onto function that can be defined from A to B or 2 power m minus 2. Here n of A, m equal to 4, n equal to 2. So required number of onto functions. Required number of onto functions equal to, that is 2 power 4 minus 2. 2 power 4 is 16 minus 2, that is 14. The required number of onto mappings from the set that consists of m elements to the set that consists of only 2 elements or 2 power m minus 2 only. Next, Coming to nature of the functions here. Next one. Coming to nature of the functions here, types of the functions, yes. This is one important problem given in previous examination. A function f from set of natural numbers to integers defined by f of n is n minus 1 by 2 if n is odd, minus n by 2 if n is even. Then f is, options are 1 1 and on to b. 1 1 but not on to, on to but not 1 1, b. Neither 1 1 nor on to, neither 1 1, neither 1 1 nor on to. Okay. The problem based on the types of the functions or nature of the function. Okay. Set. The types of the functions. Okay. Twelfth one. Given f of n is n minus 1 by n for n is odd, minus n by 2 for n is even. Where n stands for set of n belongs to set of natural numbers. So let us take for n equal to 3, we get f of 3. Since 3 is odd, functional value takes 3 minus 1 by 3, that is 2 by 3 if n is odd. This is n minus, of course this is not n, this is 2, this is 2, okay, this is 2, hence this is 2, that is 1. For n equal to 2 we get, since n is even, f of 2 is minus 2 by 2, that is minus. f of 2 equal to, this is also not minus, this is plus, this is plus. Yes. So f of n is n minus 1 by 2 for n is odd and n by 2 for n is even. If f is defined in such a way, for n equal to 3, an odd integer, f of 3 is 3 minus 1 by 2, that is 2 by 2, 1. Similarly, for n is 2 even, this is plus 1. So therefore, f of 3 equal to f of 2 equal to 1. F of 3 equal to f of 2 equal to 1, but 3 not equal to 2. F of x1 equal to f of x2. F of x1 equal to f of x2, but x1 not equal to x2. So, f of x1 equal to f of x2, but x1 is not equal to x2 follows. Hence, therefore, f is not 1, 1. It is many one function. It is, once it is not 1, 1, it is many one function. Any one function. Okay. F of n is n minus 1 by 2, n is odd, n by 2, n is even. Okay. Now coming to onto nature of the function here. Onto nature of the function. If n is odd, that is n equal to some 2k minus 1, where k is an integer, positive integer. Then f of n takes the value 2k minus 1 minus 1 by 2, that is k minus 1 itself. That is k minus 1 itself. Yes. Whereas n is even, n equal to 2k, f of n in such case is 2k by 2, that is k itself. K itself. So, k is, once k is an integer, 2k is even. K is an integer, 2k is an even number. If k is odd number, even number maps to odd number. Even number maps to odd number. If k is odd, this is even. 2k is even minus 1. K is odd, this is even minus 1, that is odd. Odd value, some odd minus 1, mapped to odd minus 1 means even. That means odd integer is mapped to even integer and even integer is mapped to odd integers. So, once f is this is also a not integer set. Actually, this is also an integer set once it is positive. Okay. So, therefore, every even integer is mapped to even integer, positive integer mapped to odd, and odd integer mapped to even. Mapped to even. Hence, all the elements of codomain n has their p images. Hence, all the elements of codomain has its pre-image. in domain. Therefore, F is onto. It is not 1 1 but onto. It is not 1 1, not 1 1 but onto. That is, C is the right option. Actually, here the printing mistake is there. F of n is defined as n minus 1 by 2 if n is odd, and n by 2 if n is even. And that function is defined from n to n itself. So here the problem printing mistake is there. Okay. Next one. Let us take one more problem. Fx is given as x plus square root of x square is a function R to R. Then Fx is, of course, 1 1, B onto, third one is bijective. That means this is injective, this is surjective, and none. Both 1 1 and onto bijective means. Okay. Here coming to the solution, Fx equal to x plus root x square, whereas F is defined from R to R. That is, Fx equal to x plus root x square may be considered as mod x. If x being positive, it is 2x for x positive, or 0 also. For x negative, it is minus x, hence 0. So, x less than 0. Okay. Whenever x is greater than or equal to 0, it is 2x, and for x less than 0, it is 0. Clearly, for all negative values of x, all the negative real numbers of x are mapped to 0. So, the function, all the negative values, including 0, minus 1, minus 2, like this, these are all mapped to 0. These are all mapped to 0. Hence, therefore, f is not 1 1. It is not 1 1. Many one function. Moreover, for x being positive, to x is positive. All the positive values are mapped to positive reals. The negative reals do not have pre-images. Moreover, from the definition, negative reals of codomain do not have their pre-images. Hence, f is not onto also, surjective also. So, neither 1 1 nor onto. So, f is neither on 1 nor on 2. So like that you can develop the nature of the, observe the nature of the function, whether it is injective or surjective, otherwise bijective, like that. Next one. Let fx equal to x square minus 4 by x square plus 4 for mod x greater than 2 and f defined from 2 to infinity to minus 1 comma 1. Okay. Then f is 1 1 b on to c bisective d many 1 onto many 1 onto. That means not 1 1 but onto, not 1 1 but onto. Okay. Let us go through the definition of the 1 1 and onto. 1 1 nature of the function. Let us observe the 1 1 nature of the function. Let us consider f of x1 and f of x2, where x1 comma x2 belongs to domain of the function. That means this one. F of x1 equal to f of x2 implies x1 square minus 4 by x1 square plus 4 equal to x2 square minus 4 by x2 square plus 4. Taking cross multiplication and on simplification, we get x1 square x2 square plus 4x1 square minus 4x2 square minus 16 equal to, taking this product, x1 square x2 square plus 4x2 square minus 4x1 square minus 16. So in such case you can remove this x1 square x2 square and minus 16 plus 16 can be removed. Therefore, collecting x1 terms we get 8x1 square, collecting x2 terms we get minus 8x2 square equal to 0. So x1 minus x2, x1 square is 0. That implies x1 equal to x2 or x1 equal to minus x2 also. F of x1 equal to f of x2 implies either x equal to x2 or x equal to minus x2. Any one follows. So therefore, f is not 1 1. It is many 1. That implies f is many 1 function. Here f is many 1. So whether it is onto or not, let us check whether it is onto or not. To check the onto nature of the function, onto nature of the function, let y equal to x square minus 4 by x square plus 4, where for y belongs to minus 1 comma 1. Y lies between minus 1 and 1. Let us consider y as x square minus 4 by x square plus 4. Find x in which it belongs to the domain of the function such that this relation follows. So that is taking cross multiplication and rearranging the terms, collecting x square terms. X square equal to minus 4y. So x square equal to 4 into y plus 1 by 1 minus y. That is, x takes the value 2 into 1 plus y by 1 minus y. 1 plus y by, of course, plus or minus. Of course, plus or minus. X equal to plus or minus 2 into root over 1 plus y by 1 minus y. Okay. Clearly this one, it may be written as actually 4 into 1, of course 2 minus of 1 minus y by 1 minus y. So that 4 into 2 by 1 minus y minus 1, which is less than minus 4, which is less than minus 4. Okay. Which lies in this interval. So, if y equal to x square minus 4, that is clearly x square is clearly y 4 into 1 plus y by 1 minus y, which is 4 into x square. Okay. That is clearly greater than or equal to 4. Okay. So y lies between. To define x, y must lie between so x, whenever x lies between these two, this one 2 into square root of 1 plus y by 1 minus y is more than 2. More than 2 means 1 plus y by 1 minus y is greater than 1. From this let us consider y. Y means 2 minus of 1 minus y by 1 minus y greater than 1. That gives us 2 by 1 minus y is greater than 2. So 1 is greater than 1 minus y. So 2 by, that means 1 by 1 minus y is greater than 0. Hence 1 minus y is negative. 1 minus y is negative. So 1 is less than y greater than 1. So this is positive, means this one is positive. Hence this is greater, this is less than. Y less than 1 follows. So clearly there exists x, which lies between 2 and infinity once taking plus, which lies between 2 and infinity, such that y lies between minus 1 and 1. Similarly, taking minus, x lies in this interval. So therefore x equal to plus or minus 2 into root 1 plus y by 1 minus y belongs to domain of f itself. Once taking plus, x value lies in this interval. Once taking minus, x value lies in this interval. So that x, either taking plus or minus, it belongs to the domain of the function. So certainly there exists a pre-image for every value of every element of the codomain. So f is onto. Therefore f is many one onto function. Many one onto function. It is not one, but many one onto function. Next, this is also given in examination, 0 to infinity to 0 to infinity, and fx equal to x by 1 plus x, then f is either 1 1 onto but not 1 1, like that. The nature of the function is. Okay. Here fx equal to x by 1 plus x itself. X by 1 plus x. That is 1 minus 1 by 1 plus x. And f dash x is 1 by 1 plus x whole square, which is positive for all x that belongs to domain. So the function is increasing function. Therefore, f is an increasing function. Since f is increasing function, it is clearly 1 1. It is clearly 1 1. Moreover, x does not take the value of course minus 1. There is no minus 1 here. Okay. So therefore, f is 1 1. 1 1 function. Coming to onto nature, let y equal to x by 1 plus x for y belongs to codomain. Codomain of f. That means y greater than or equal to 0. That is y plus xy equal to x. X into y minus otherwise y equal to x into 1 minus y. That is x equal to y by 1 minus y. The domain of this function, the domain, taking the domain of this function, y is not equal to 1, of course, which is not, y takes the value 1 also, y takes the value 1 also, but corresponding to y equal to 1, there is no image in the domain, okay, which is defined, which is not defined for y equal to 1. Y equal to 1 is in codomain. Therefore, for 1 there is no, therefore 1 for 1 in the codomain there is no pre-image. There is no pre-image. Once y equal to 1, there is, you cannot find x in the domain. So that therefore one element is sufficient in such a way so that the function is not 1 1, no, not onto. So f is not onto. The function is not onto. It is only a 1 1 function, but not onto. But not onto. This is onto 1 1 but not onto. That's right. The function is 1 1 but not onto. Okay. So f is 1 1 but not onto. So like that you can develop the nature of the functions.